Hello students, welcome back to the new session. We are going to discuss about the last topic in this unit, third unit, that is Lidar. It is a type of laser sensor. We are going to see that in detail in today's class. So these are all the topics we have seen, and today we are going to see laser range sensor. It is in short, it is known as Lidar. So Lidar is the full expansion to Lidar is light detection and ranging. It is also a type of range sensor. Lidar laser range finders are perhaps the most accurate sensors for measuring distances. Light distance and ranging systems use the time taken by the light to fly back and forth to an object in an effort to measure the distance of this target. So you have target, so we are sending light and we are retrieving that back, and the time travel, the light travel is taken into account to measure the range. Building a Lidar system can be made with either a high-speed analog to digital converter or a time to digital converter (TDC). Lidar systems are one of the three techniques. It is pulsed modulation technique, amplitude modulation continuous wave technique, frequency modulation continuous wave technique. So these are the three techniques used in Lidar systems. So active sensors for mapping terrain. Radar transmits microwaves to pulses determine distance to objects and their angular position from sight. Lidar transmits optical laser light in pulses determines distance to objects. So history, if you see, the Lidar came into picture in laser ranging developed in 1960s. Lidar terrain mapping began in 1970s. Initial systems were single beam probe filling devices. Early use of terrain mapping limited by lack of accurate georeferencing. So early systems used for development of GPS and inertial navigation systems, that is measurement systems for improved accuracy. So Lidar platforms, aerial for highly detailed local elevation data, satellite covers large areas with less detail. Lidar operational theory is a pulse of light is emitted and the precise time is recorded. The reflection of that pulse is detected and the precise time is recorded. So pulse is sent and the reflection is recorded. The time of reflection is also recorded. Using the constant speed of light, the delay can be converted into a slant range distance. Knowing the position and orientation of the sensor, the XYZ coordinates of the reflective surface can be calculated. So this is how the Lidar works. Components of a Lidar system: laser scanner, high precision clock, GPS, IMU inertial navigation measurement unit, data storage and management systems, GPS ground station. So components frequency 50K to 200K pulses per second. Wavelength infrared is used for meteorology Doppler lidar. Near infrared for terrestrial mapping. Blue green for bathymetry. Ultraviolet for meteorology. Eye safe for low wattage. So this is the spectrum. So visual, that is the light spectrum. So here you can see the visible light is here, and this is the frequency band used by lidar system. So optical sensors plus lidar up to here, and only this much is visible light, only this much in the spectrum is invisible. All other UV and X-ray, we have gamma rays, and this side we have infrared and radio waves. So these are all not visible waves. So these are all not visible frequencies. Only visible frequency ranges this much. Only this is smallest band of the spectrum is visible wave. So this is known as electromagnetic spectrum. Working of laser. High voltage electricity causes a quartz flash tube to emit an intense burst of light, exciting some of the atoms in a cylindrical ruby crystal to higher energy levels. So this is the electricity, high voltage electricity causes the quartz flash tube to emit an instant burst of light. So that is how the laser is formed. At a specific energy level, some atoms emits particles of light called photons. At first, the photons are emitted in all directions. Photons from one atom stimulate emissions of photons from other atoms, and the light intensity is rapidly amplified. Mirrors at each end reflect the photons back and forth, continuing this process of stimulated emission and amplification. The photons leave through the partially silvered mirror at one end. This is the laser light, and the emitted light waves are in phase with one another and are so nearly parallel that they can travel for long distances without spreading. So this is how laser is formed. So components of Lidar system, the scanner, the mirror spins on or scans to project laser pulses to the surface scanning angles up to 75 degrees. The scanner measures the angle at which each pulse was fired, receives reflected pulse from surface, so that is the return pulse. So this is how the laser beam works. So this is the laser beam, it is hitting the scanning mirror, and from here it is sent to the ground location, and few beams are reflected here to low altitude collection, and again the reflection is taken back, and the reflection is measured back again. So this is how the lidar system works. So working of the lidar here, global positioning system, it records the XYZ location of the scanner, the surveyed ground-based stations in the flight area. The inertial measurement unit, IMU, it measures the angular orientation of the scanner relative to the ground, so that is pitch, roll, and yaw. Clock records the time of the laser pulse leaves and returns to the scanner. So this is the working of lidar. Principles of airborne lidar. This is also known as flight planning. So cannot penetrate clouds are often flown at night. Overlap of 30 to 50% steeper terrain, multiple passes at different angles in urban areas to avoid lidar shadow. So flying elevation typically 200 to 300 meters higher in urban areas. Multiple returns are received for each laser pulse fired from the scanner. Modern systems are capable of recording up to 5 returns of each pulse. So the range distance between the sensor and surface object is calculated by comparing the time and the pulse left the scanner to time each return is receiving by XYZ coordinates of each return is calculated using location and orientation of the scanner from the GPS and the IMU. The angle of the scan mirror and the range distance to the object, the collection of returns is known as a point cloud. So it is a 2-mark question, point cloud. So disadvantages of lidar: inability to penetrate very dense canopy leads to elevation model errors, very large data sets that are difficult to interpret and process, no international protocols. So cost is a little high, around 200 to $300 per square mile. 3 meters resolution and 350 to $450 per square mile for 1 meter resolution. So when our resolution goes higher, there the cost also goes higher. So applications: the factory automation optical proximity sensor. So factory automation optical level sensor, factory automation volume scanners, so drones. So these are all the applications. And books on Lidar, there are very good books available. I will upload in Google Classroom for your reference. So there ends the syllabus of Unit 3, and we are going to start the next unit on signal conditioning in next session. So there we are completing Unit 3 here. Thank you, students. Thank you.